Today, we're looking at ratio, rate, and proportion, and again, we're finding different ways to actually apply them. Okay, so what our goal is today, I can determine missing measures in scale and other proportions. So first of all, scale. Scale is the relationship between a measurement on a drawing and a measurement of the actual object. So we see this in a lot of different ways. We see this when we're reading road maps. Also, we see this in drafting, and we see it in science as well. And the reason being, when we draw something, we often don't draw it to the actual size of the object. Okay, so we have to make some adjustments that way. So when we're reading a scale, okay, we have like 1 to 100 or 100 to 1. So what we're looking at, first of all, in the first position of a scale, what that is that's the measurement of a drawing. Okay, one part of this is on the paper, and then the second number is the measurement in real life. Okay, so the measurement on the paper, the measurement in real life. Now, the thing is, another thing that we need to be aware of is that the units of measurement between the drawing and the real life can be different. So in other words, if we're looking at a road map, for instance, if we're looking at this as being 100 kilometers, obviously on the paper, we're not going to have one unit representing 1 kilometer because again, that would be too large. So for instance, on a road map, it could be 1 centimeter on the drawing translates into 100 kilometers in real life. Okay, so these units don't have to match. All right, so let's take a look at some examples. Sorry about that, I got kind of a frog in my throat. So, very easy one. Determine the distance between Mitchell and Seaforth if they are 0.33 centimeters apart on a map that has a scale of 1 to 75, where we have centimeters to kilometers. All right, so take a closer look at this. I'm going to just bring it up for us. So what do we know? Well, the first thing that we know is we have 1 to 75. Okay. We also are told that on the map, the two items are Mitchell and Seaforth are 0.33 centimeters apart. So that is on the paper, so it matches with the 1. What I'm trying to figure out then is how far apart are they in real life? So if you notice, set up very similar to what we were looking at before. So we need to find the relationship between them. So what is the relationship between 1 and 0.33? Well, obviously what we've got there is we're multiplying 1 by 0.33 in order to get that. So the same thing should be true then if in real life, if I take the 75 kilometers and multiply it by the 0.33, which I've done here, we end up with 24.75. So really what we have found then is that the distance between Mitchell and Seaforth in real life is 24.75 kilometers away. All right, so we set it up very similar to what we've been working with already. Now let's look at another question. Now again, if you noticed here, I have in brackets shadow. Now the reason I put the word in shadow is here is often they use this a shadow type question on tests on EQAO. You often see them. Okay, so what we have is a 200-meter tall building casts a shadow, sorry, that should be a space in there, of 45 meters long. If you are approximately 1.5 meters tall, determine the length of your shadow. Now, the first thing I'm going to do here is there's a situation here that I'm going to just draw a picture. Okay, so I have the ground here. I know that I have a building, and let's make my building blue. So here is my building. and they tell me that it is 200 meters tall. And so I'm just going to put 200 here. And I'm told it has a shadow that is 45 meters long. Now, I don't know if I'm really am 1.75 meters tall. So then we have a person, which they're saying is us, one of us, and we're standing at the same time, and we're told that we're 1.575 meters tall. Okay, and we want to know how long our shadow is. Obviously, it's going to be less than 45 meters because we're a lot shorter than the building. So what we're comparing here is the building with the shadow. Okay, so we know the relationship between the building and the shadow. And we know that that relationship, according to here, is 200 meters. As soon as I find it, there it is, 200 meters to 45 meters. Oops, to 45 meters, which is somewhere else, and that's not where I wanted it to be. Um, and those are the wrong numbers, so just hold on a second. Okay, back again. That's what happens with technology sometimes. So let's take a look at this question again. So we have building to the shadow. The building is 200, and we know that its shadow is 45. Okay, so I've put this here so that I remember building to shadow. Okay, so what I'm interested in is the person who is 1.75, and I want to know what its shadow, what that person's shadow is. So that's what I want to find out. Okay, so again, the same kind of setup that we had before. So we need to know the relationship between 200 and the 1.75. And we also need to know that then we can use that relationship to find out the shadow of the person. Okay, so what do I multiply 200 by to get 1.75? Well, to tell you the truth, I have no idea. However, I can go the other way and go 1.75 divided by 200. Okay, so if you notice I have decimal 00875. So let's check that just to make sure that that's correct. So it means if I have 200, I multiply it by decimal 00875, I should get the 1.75, which we do. So therefore, I know then if I take the 45 and multiply it by that decimal, I should get the correct answer. So that's what we would do. And so we would go 45 times the decimal 0.0875. And when we do that, and let's just bring up our calculator again, so clear it. So 45 times decimal 875, we end up with decimal 393, so decimal 39. Okay, so if we are a person that is 1.75 meters tall, then our shadow would be decimal 39 meters long. Okay, if it was done at the same time that this building's measurement was done. So we also need a therefore statement. So therefore the shadow would be decimal 39 meters. Now I've set up this ratio and this proportion this way. I could have set it up a little bit different as well. I could have put real life over here and shadow on the other side, and it would work out the same way and you would get exactly the same answer. Okay, let's look at the next question. The next question is different again. We're talking about the exchange rate. Okay, and if any of you have ever traveled to another country, you know that when you go to another country, you have to use their currency. So you take your Canadian money and you convert it. And at different times and in different countries, the conversion rate is different. So here we have alien money that we have, and they're called Zorgs. So the exchange rate for Canadian to alien Zorgs is $2.25 Canadian equals 1 Zorg. So if David just completed his intergalactic space tour and has 45,000 Zorgs left, determine how much Canadian he has. Okay, so let's find out exactly whether David is rich or not. So first of all, we are comparing obviously Canadian money to Zorg money, right? So we're comparing Canadian money to Zorg. And we know that according to this, that $2.25 in Canadian is the same as 1 Zorg. So I'm interested in how much Canadian money will I have if I have $45,000 or sorry, 45,000 Zorgs left. Okay, so I have to again look for a relationship between our numbers. Well, the 225 goes with the Canadian money. I don't know enough information to solve that. I do know that 1 multiplied by something will give me 45,000. Obviously, the number would be 45,000. So if I take David's $2.25 and multiply it by the number of Zorgs he has, I should have the amount of money that David has. So we have 45,000 times $2.25 equals 101,250. So actually David's a pretty rich guy. So now we have, therefore, he would have $101,000, 250. Okay, so you get to have some fun with some conversions with currency in your work that you're going to be doing tomorrow in class.